I am Dr. Nikita Sharma, Associate Professor, Department of Chemistry, SPNKS Government PG College, Dausa. Today we will start Green Chemistry of MSc Previous. What is green chemistry? Green chemistry is the utilization of a set of principles that will help reduce the use and generation of hazardous substance during the manufacture and application of chemical products. Green chemistry aims to protect the environment not by cleaning up but by inventing new chemical processes that do not pollute. It is a rapidly developing and an important area in the chemical science. Green chemistry, also called sustainable chemistry. It is an area of chemistry and chemical engineering focused on the designing of products and processes that minimize or eliminate the use and generation of hazardous substance. While environmental chemistry focuses on the effect of polluting chemicals on nature, green chemistry focuses on the environmental impact of chemistry, including reducing consumption of non-renewable resources and technological approaches for preventing pollution. Need for green chemistry. There is increasing pressure from both society and governments for chemistry-based industries to become more sustainable through development of eco-friendly products and processes that both reduce waste and prevent toxic substances from entering the environment. Principles of Green Chemistry. In 1998, Paul Anastas and John C. Warner published a set of principles to guide the practice of green chemistry. The 12th principle addresses a range of ways to reduce the environmental and health impact of chemical production and also indicate research priorities for the development of green chemistry technologies. The principles cover such concepts as: first is the design of processes to maximize the amount of raw material that end up the products. Second is the use of renewable material, feedstocks and energy resources. Third is the use of safe, environmentally benign substances, including solvents whenever possible. And fourth is the design of energy efficient processes. Fifth is avoiding the production of waste, which is viewed as the ideal form of waste management. Now the 12 principles of green chemistries are: first is prevention. Prevention means preventing waste is better than treating or cleaning up waste after it is created. Second is atom economy. Atom economy means synthetic method should try to maximize the incorporation of all materials used in the process into the final product. This means that less waste will be generated as a result. Third is less hazardous chemical synthesis. Means synthetic method should avoid using or generating substances toxic to human and or the environment. Fourth is designing safer chemicals. Means chemical products should be designed to achieve their desired function while being as non-toxic as possible. Fifth is safer solvents and auxiliaries. Auxiliary substance should be avoided whenever possible and as non-hazardous as possible when they must be used. Sixth is design for energy efficiency. Energy requirement should be minimized and processes should be conducted at ambient temperature and pressure whenever possible. Seventh is use of renewable feedstock. Renewable means repeatedly. For example, solar energy. Whenever it is practical to do so, renewable feedstocks or raw materials are preferable to non-renewable ones. Non-renewable, for example, carbon-based fossil fuels, oil and petroleum. Eighth is reduced derivative. Reduced derivatives means unnecessary generation of derivatives such as the use of protecting groups should be minimized or avoided if possible. Such steps require additional reagents and may generate additional waste. Now catalysis. Catalytic reagent that can be used in small quantities to repeat a reaction are superior to stoichiometric reagents, ones that are consumed in a reaction. 10th is design for degradation, means chemical products should be designed so that they do not pollute the environment. When their function is complete, they should break down into non-harmful products. 11th is real-time analysis for pollution prevention, means analytic methodologies need to be further developed to permit real-time in-process monitoring and control before hazardous substance form. 12th is inherently safer chemistry for accident prevention, means whenever possible the substance in a process and the form of those substances should be chosen to minimize risk such as explosion, fires and accidental releases.